This is the assignment 1 part B. So as you can see in your assignment 1 document, you can see part B, so section 8, that has all the information you need for when the demonstration are due. Now let's look a bit further down. If you look at section 9, it says system operation locked mode. So when the system is powered up, it should enter locked mode. So the 7-segment display should show the first 2 digits of your student number followed by EEEE for the last 4 digits. So as you can see on my board down here, the 7-segment displays are showing that. So you have 11, which are the first 2 digits of my student number, and EEEE to round it up. Now, so that's initialization, system initialization. Now let's look at the password sequence. So to enable the system, you need a password derived from the last 4 digits of your student number, and it'll be represented by 1 if it's odd, and 1 if it's even, and 0 if it's odd. So for my case, my password would be 1101. And then each time a correct sequence is entered, the E's should slowly reveal the last 4 digits. So if you kindly look down here, as I entered the first number, that shows the first one. Second number shows my second one. And let's say if I put an incorrect sequence in, that resets to EEEE. And similarly, another incorrect sequence. There we go. And then there we go. And another incorrect sequence. Right. So once the correct sequence is entered, the system should exit locked mode and enter clock mode. So when it's in clock mode, the bar LEDs should light up and remain lit without visible flicker. So let's look. The bar LEDs are the LEDs up here. So you have 8 up here, those are your bar LEDs, and these 4 dip switches and the 4 buttons on your MXK. So as you can see, as I input the correct sequence, now the bar LEDs remain lit without any visible flickering. And now we enter clock mode, which is section 11, clock mode part 1. So the system now enters a clock mode, so the last 4 displays function as a clock. First 2 displays continuing to display the first 2 digits of my student number. So if you look in my case, last 4 digits for me are 8056, so it will take roughly 80 seconds before it resets. So let's, in the meantime, look further in the documentation. So as you can see, if your student number is the last 4 digits of your student number is less than 1000, you will then add 1 to the 5th digit. So if you have 123402334 or 1234000, for the purpose of this assignment, you would become 12341234 or 1234100. Now, section 12 is clock mode part 2. So this is actually a challenge for this assignment. The tutors will not be giving any direct help with this section. All the components required to make this happen has already been taught to you in your lab videos and during the labs. So it is up to you to then find a way to make this part of the second part of the clock mode be realized on your MXK. So as you can see up here, when dip switch 1 is, when both of them are off, it should operate about 100 Hertz. When dip switch 1 is switched on, it should speed up. So let's look at my example. As I switch that on, that speeds up ever slightly. We're not going to be too pedantic on whether it's double the speed, but we just need to see a visible increase in the speed. So as we switch down switches, you can see that it slows down slightly. And now that basically slows down a bit. and when it's off, it's quicker. And then similarly, when dip switch 4 is on, it should halve, or it should slow down. So it should, there you go, it should double up. There we go. Notice how it's going to reset now. So my number is 80, so you can see it's going to reset now. So when it reaches the last 4 digits of your student number, it should reset as per clock mode part 1, which is up here. So when the clock is equal to the last 4 digits of your student number, the system should reset the clock to 0 and continue the count. Now, in relation to clock mode part 2, when both dip switches are on, your clock should pause. So in our case, as you can see, let's do that, speeds it up. And that pauses the clock. And there we go. As I pull it down, that's going to come off. If I leave it up, it's going to be paused. And that is your assignment 1, part B. So do remember, as mentioned in the labs, go through the marking schemes. They're quite objective in what which sections would give how many marks. So for example, if you're unable to do the last part, which is to pause the clock, or if you're unable to do that section, that's only worth 3 marks out of the 15 for assignment 1, part B. Similarly, if say when I reset it at the EEE, and say you couldn't show the sequence recognizer, you could potentially set up your reset button, so your LED, your button on your FPGA, to simply unlock the system, just so you can still get assessed and marked for clock mode. And similarly, if you're able to unlock it without a working sequence recognizer, so if you had a way of working around it and your bar LEDs are open when it's unlocked, you will still get that 1 mark in there for that section. So bar LEDs all light up when system unlocks without flickering. So as mentioned in the documentation, if you think you can't implement the whole assignment, decide to implement part of it, then we expect to see some outcomes. If you come to the demonstration and said, everything works except for this sequence recognizer, thus I can't show you clock mode, our hands as tutors will be tied, because we're only able to mark on what we see on the boards itself. So even if you have all the code on Xilinx and that you can show to us, you will not get assessed on that. You will be assessed on the actual physical results out on the MXK board hardware itself. So hopefully this has cleared up or helped you guys understand a bit more about the assignment requirements. Once again, do go through the sections if you're still unclear. It might be worthwhile using block diagrams to help you understand what's required and where the different components can fit all together. So for example, so let's reset this. So as you can see, as I enter the correct password in, that's the password recognizer, which is a sequence recognizer. So that's something you can sort of fit inside this puzzle. And the counting clock, and you can sort of correlate, maybe the BCD counter counts something up from 0 to 9, so can we make a clock out of it? So that's something for you to think about, something for you to spend time to design, not only on paper but also on your Xilinx. And at this stage, once you have this control architecture to be able to show the 6 numbers, when you initialize it. If you're able to show 11EEE, the quickest way to then start debugging your code is to just actually upload it onto your MXKs and look at the outputs. So for example, if in this example, say what's displayed is EE1111, you can make out that, okay, so everything supposed to be switched on is switched off, and everything that's supposed to be off are switched on. And then you can identify that problem and fix that bug or fix that issue in your code itself. So once again, this is just a quick clarification for assignment 1 part B. So do have a look through the assignment sheet again, and do remember that the assignment template for this assignment, the template project for this assignment, is available on UTS Online. If you have any other questions, please put them on the discussion boards in assignment 1, or bring these questions into the labs when we have tutors walking around to help you.